Okay, today, guys, we're going to go through surface area. We're going to work today on the prisms. We'll probably be doing the pyramids next class. But what we're doing is we're taking solid figures in 3 dimensions, and we're now going to find out basically what we have on the outside of them. So far we did area, which is 2 dimensions, in flat figures. We did volume, which is how much goes inside of these 3D figures. Today we're going to do surface area, which is saying how much area, the 2 dimensions, do we have on the outside of these 3-dimensional figures. Make sense? Yeah. Don't worry, we'll get to a couple exercises that'll help you understand that. But before we do that, let's just do a quick review. We want you to calculate the area of the composite figure. So it says 1 to 2 minutes. We'll give you 3, but take 3 minutes. Try to get as much of this knocked out as you can. Go.
All right. There are 2 ways to find the area of this composite figure. Who can tell me both ways? Not walk me through it, just tell me the 2 ways. What would we do?
You can split it into 1 square and 2 rectangles.
Okay, you can split it into smaller geometric shapes, or
you could split it here.
Okay, that's also splitting it and decomposing it into smaller geometric shapes. What else, Harper? You can make it one big rectangle and then just take away the part that's missing. We're going to decompose it into smaller shapes for the example. So I'm going to decompose it this way, and I'm going to start with the bottom right rectangle. What is the area of that bottom right rectangle? 8, length times width, and they're both labeled for us. So it is 8 yards squared. What do you notice about the top right rectangle? They're the same. Because if this is 4, that means this is also 4, and this is 4. Yes? So what's the area? 8 yards squared. Then we have this shape, and one side is labeled. I know this is 6, but what about the top and the bottom? Layla with an E, A? Ten minus what? 4, because we've already taken away 4 when we did this rectangle, yes? So how much does that leave us?
6.
6 out of our 10. So what is 6 times 6? 36 yards squared. Now how do I find the area of the total composite figure? I'm going to add them together. So I have 36. What is 8 plus 8?
16.
So 36 plus 16 is 52 yards squared. Does anybody have any questions about how we found the area of that shape? All right, let's look at the next page. I am coming around to hand out something to my side, and Mr. Moore will hand his side. And please do not do anything until you have other directions. All right, guys, so you were just able to use your net, that is what that is called when it is flat, to fold and build a 3D cube. How many faces does your cube have? Can I borrow this?
That's your just.
It has 6. It has a top and a bottom, a right and a left, and a front and a back. Yes? How many edges does your cube have?
12.
It has 12. It has 4 around the top, 4 around the bottom, and 1 on each side. So there are 12. How many vertices does it have? What are vertices?
8.
It's the corners. How many corners does it have?
1 at a time. Raise your hands.
I'm more worried about the ones that aren't shouting out answers. There are 8. Thank you. 8 corners. Thank you. All right, so now that you see how a net is folded into a cube, they give you several different pictures of nets. And it says, circle the 11 nets that can be folded to form a cube. So you're going to look at these nets, and you should have 11 circles when you have finished of the which ones you can fold to form a cube. It should have 6 faces, 12 edges, and 8 vertices. Go for it. We're giving you about 4 minutes.
Okay, we're just going to go through these a shape at a time. If you think that it is a cube, raise your hand. So our first one, how many do you think this one forms a cube? Raise your hand. Good news, you're all correct. That one will. What about our second one? Raise your hand if you think it makes a cube. Also well done. That one does not. How about our third shape? No. Why not? Yes? It only has 5 faces, guys. There's no way that makes a cube. That was like the easiest one on the entire page. Okay. Guys, our last one on that line. Guys, quiet down. Raise your hand if you think it makes a cube. Most of you, y'all are correct. There were 2 in that line. Okay, our next line. Will the first one make a cube? Raise your hand if you think it does. Does that first one make a cube? It does. What about our second one? Raise your hand if you think it does. Bach, you don't think that one did? You're supposed to already have that done. That one also does. Our third one. Does that one make a cube? Raise your hand, yes. Ooh, my side didn't do so well on that one. That one will also make a cube. What about the fourth one in that one? Will that one make a cube? Raise your hand. That one does not. Okay, next line. Will the first one make a cube? Raise your hand. No. Second one? Also a no. Third one? Raise your hands if you think it's a yes. Good. That one does. The next one? That was actually what you guys just did. It's just turned sideways. Okay, next line. Will the first one make a cube? Raise your hands. Good. How about the second one? No, that one won't. Or will it? No, because it's going to fold back on itself. The top would be empty. What about the next one? Raise your hands if it's yes. That one is a yes. How about our next one? Again, that one's got 7 faces, so there's no way that can make 6. Next one? Nope. It's going to fold over on itself. The next one? Yes. Good. The next one? Nope. Last one? Yes. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We got all 11. Then you were wrong. Figure out which one you missed. Yep. I'm sorry? Okay. So guys, let's look at this real quickly. How did you determine which are nets of cubes? What were you guys doing? What helped you figure that out? What process did you go through to see if it was a cube or not? Giovanni?
Using your brain.
What?
Using your brain. What? Using your brain.
Using your brain. How did you use your brain? What was your technique? What did you do? Yes? Good. So they had to have 6 faces. Anything else you noticed? John?
What I noticed was that they have some similar shapes.
What do you mean by that?
I mean, like, there's a couple that looks exactly like the one we did.
Okay. So once I've determined one shape works, that any shape that looked like that also works, right? But I would hope most of you, what you were doing is kind of mentally folding it to make sure it had all 6 faces, right? So mentally fold to make sure it had 6 faces. So why do you think we did this whole exercise? Use our brain. That is a big piece of it. Yes?
I think it was so since we did the cube, so we could imagine like we're folding it.
Okay. Good.
Try to get used to it.
Now, I want you guys to look at the cube you've just made. Oh, sorry, Layla. Not so much, but we'll get to the big reason in a minute. Well, that would indicate you had some, but yes. Okay. I want you guys all to look at the cube you have made. Think about the definitions we gave you the other day. What do all of the nets have in common? Look at the number of faces, edges, and vertices. So how many faces did every one of these cubes have? 6. We have 6 faces. How many edges? 12. 4 around the top, 4 around the bottom, 4 around the sides, right? So that's 12 edges. How many vertices? 8. 8 vertices. 4 on top, 4 on bottom. So is everybody good so far in what we've done? Okay. Let's turn. Okay, if you guys turn the page, or that's your next page. Okay, everybody needs your highlighter. There it is. So get something to mark your text. Doesn't necessarily have to be a highlighter, but something so you can see what you're doing. Guys, quiet down. So here's our big one. Today we're talking about surface area. When we talk about surface area of a polyhedron, it's the total area of all its two-dimensional faces. So you can think about surface area as the total area covered by the net of the solid. In other words, if I take the solid and laid it out into a net and find all of those surface areas, that gives me my total surface area. So really what we've just done is made a composite figure out of your third three-dimensional figure. So why did we have you guys do that? Because we basically just we're doing the reverse. We wanted you to see that that two-dimensional figure makes a three-dimensional figure. So that if I find the surface area, all I need to do is go back to that net and find out what all those areas equal up to. So let's look at this. How is the area of a face of a cube measured? Analyze the two responses and explain why Letitia is incorrect in her reasoning. I want you guys to talk about this at your table. So read what Letitia said, read what Isaiah said, figure out why Letitia is wrong. Okay, as you talk about it. I'm sorry? Oh, John heard it. He's like, what was that? That's what I said. It's her way of getting people quiet down. Guys, so what was wrong with Letitia's reasoning? It is a 3D figure, right? So why is she wrong?
Because you don't use cubic inches.
Why not? Isaiah gave us a really good indicator of why she was wrong. Because it's what? Area. Surface area is area, so it's still measuring an area. So it's always measured in square units. Back when we were doing the 2D figures and we said area will always be square units because I'm multiplying two parameters, a length and a width, or a base and a height. There's always two. Surface area doesn't change that. Even though it's a 3D figure, I'm only looking at the outside of it. Make sense to everybody? So, again, if I'm looking at a 3D figure, for volume, I need what would fit inside of it. That's cubic inches, feet, whatever measurement we're using. Surface area is just saying I'm covering the outside. So all I care is what the outside looks like. Make sense to everybody? Okay, that's one of the big mental concepts we need to get you to leap through on this. So describe a strategy you could use to determine the surface area of a cube. What do you think you could do? And we gave you a good indicator, right? I could make a, Layla? You know what that's called? Good. So you can draw a net to find the area of the pieces. So that is actually a really good strategy to use. The downside to that strategy is sometimes it's kind of difficult to make a net. So let's look at another one. Here we've got a net for you. So how did we get down to 12 minutes? Yes, we can. I think you were just talking too much today. So let's look at the cube we have here to calculate the surface area. Now, there's a huge piece on this. We are talking specifically about cubes. What an important piece of information we know about cubes that we're going to use to find areas? Layla? It has 6 faces. That's extremely important. All the sides are equal. So even though they only gave me one measurement, that's really all I need, isn't it? Okay? So we know area is length times width. So the way I've taught my students is I just go straight to the figure. Which was my length? The 2 or the 2? The 2, right? So that means that the 2 is my width. I can label it right on my picture. Now all I have to do is put those numbers into my formula. Area equals 2 inches times 2 inches is 4 inches squared. But the other piece of information we said was how many of these are there? 6, and they're all identical, right? So for a cube, I could say it's 6 times the length times the width, or 6 times that quantity, which gives me 24 square inches. Does that make sense? Why not? I said 1 square of the cube, has an area of 4 square inches.
Oh, there's 6 squares.
There are 6 of those squares in a cube. 6 times the length times the width. Now, there's one extra piece we could actually build in here. Because it's a cube, what do I know about the sides? They're the same, right? So we've gone through exponents. So instead of length and width, I could say area is 6 s squared, where s is the side length of the cube. So that is a formula that will work just for cubes. But if it's a cube, all I need is that one measurement, that side length. I'm going to multiply it by itself and then times 6 because there's 6 faces to the cubes. So please make sure you have that formula written in your book. Now this one looks a little different. The surface area of a unit cube. So here we got to get back to that definition. Who remembers what a unit cube is? Autumn? That's what we packed inside of them. But what's it specific about a unit cube? Legend? It's 1 unit. That means that my S for the unit is 1. 1 squared equals 1. 1 times 1. 1 times 1 is 6. 1 times 1 is 6. 1 times 6 is 6. So, for a unit cube, area will always be, or the surface area, is always going to be 6 of whatever unit it is. So it doesn't matter if it's centimeters, inches, feet, meters, kilometers. I don't care what the unit is. If it's a unit cube, it means that the side lengths are all 1, meaning it has a total surface area of 6 of whatever that unit is. Make sense? Because my side length is 1, it's going to work just like that. Okay. Unfortunately, we don't have much time left, so I'm going to walk through this one with you guys. If I were to look at this, how would I describe the dimensions of the faces on the net that are on opposite sides? In other words, this net I'm looking at, how does this side relate to the other side? Legend? Rectangles and flat 2D.
Unit cube.
Not necessarily. We don't know that until not right. There are right angles on them.
There's 2 of both of them.
Two what?
There's 2 of both of them.
2 of both. They're the exact same, right? And if I look at it from the side, on the side, that one would be the exact same as that one. Make sense? Everybody good? Okay. So looking at the one that they've given us, this is actually a net of this. They only gave me 3 numbers on this entire picture, though, didn't they? Yeah? So just like we did our solid figures, if I just label my shapes, 1, 2, 3 for green, blue, brown. If I'm trying to find the surface area, the area for figure 1, area is length times width, but they only gave me a 3. How do I get a second measurement on that? I fold it, and I say, okay, well, they said this is 4, right? But if I were to fold this side is going to match up to this side, isn't it? Meaning that this side is also how long? 4. So I know that this is 4 centimeters. Does that make sense? Anybody not see that? Because this is really important. You have to be able to see from that picture where that 4 comes from. If you've got that, now I know it's length and width. I'll say my length is 3, my width is 4. So for the area on the first one, it's 3 centimeters times 4 centimeters, or 12 centimeters squared. For our second shape, 2 is the blue. This one's a little easier because they gave me the 4 here. Well, I've got the 6. I can see that 6 goes all the way across, right? So I still need length times width. So I'm going to say that my length is 4, my width is 6. Gives me an area of 4 centimeters times 6 centimeters, or 24 centimeters squared. And for shape 3, this one is actually pretty easy as well, because I can just say, okay, this brown is the same as this brown, right? Meaning this is 6 centimeters. This comes straight down, so that's also here. So for our third one, my length and my width, I have a length of 3 and a width of 6. So area equals 3 centimeters times 6 centimeters, or 18 square centimeters. Does everybody see where all those numbers came from? More importantly, does anyone not see where those numbers came from? Okay, at this point, how many green shapes do I have? 2. So if one of them is 12, 2 of them would be 24. How many blue shapes do I have? 2. So if one of them is 24, 2 of them would be 48. So on our last shape, how many of the browns do I have? 2. So if one's 18, 2 would be 36. So to find the total area of my entire figure, I would take 24, 48, and 36, add them together. Gives me 10, 18, 6, 10. So don't forget your units. So the surface area for this whole figure is 108 centimeters squared. Does that make sense to everybody? So there's another way to look at this for a right rectangular prism. Surface area, what did I have to do to the first box? Multiplied it by 2. So I said length and width plus 2 times the length and height plus 2 times the height and width. So add that formula in. That's one of the formulas you should get used to. That way, if they give it to me in 3 dimensions, all I need to do is label my length, width, and height, and I can easily find the surface area. Because I'm just doing 2 times each of those and then adding it all together. Questions? Jane, did you get that written down? Okay. Homework tonight, again, 2 Matthew workspaces. That should be your 19th and 20th workspaces total. Hey guys, have a seat. Have a seat. What are you doing, Legend? Guys, remember, next week is the end of the quarter. Any missing work, all Matthew, needs to be done by next Thursday. Next Friday, you guys don't come to school because Miss McShannon and I are putting in our final grades. Make sure you're ready for it.